All right, hello everyone, and we'll start with a problem that I think many of, if not all of you, have encountered one way or another at some point. Certainly been using Oracle database for a while. I think it'll be familiar. So you've got a query that looks a little bit like this. We're filtering on a date time column, and we're checking whether it's greater than a particular value. So in this case, we're saying yesterday, so the 16th of February, and you get some data and, it all looks like it works. So someone says, let's just get it into production, deploy it, have it run there, release the code to production. And what happens? You run the query, and instead of getting results, this time you get like the literal does not match format string, or one of several other data type conversion errors you might get here. And, you scratch around puzzling and go back to the developer who originally created, and they're like, well, it worked on my machine, right? It seemed good to me. What's the problem here, right? So there's lots of things to kind of unpick around this, and we're going to see how you should work correctly and effectively with date time types in Oracle database. And so, hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's app dev team. It's my job to help you get the best out of Oracle SQL and PL SQL, and hopefully have some fun whilst doing so. So with that in mind, as I say, we are going to be talking about working with date time values. And right at the very start, very important thing to be aware of is that date times are complicated. There is a lot of unavoidable complexity when it comes to working with date time values. There's a great site, or it's actually a GitHub thing, where someone has cataloged huge, big, long lists of falsehoods programmers believe about time. If you've been around for a while, you'll almost certainly be nodding your head and agreeing with most of them, or many of them. But I'm sure there's some things in there which will be a surprise or new to you. I certainly learned a few new things whizzing through that. So there is just a lot of unavoidable complexity when it comes to working with date time values and durations. Because unfortunately, we've got 7 days in a week, but the number of days in a year isn't an exact multiple of 7. And, there isn't actually a fixed number of days in a month, and so on and so forth. So there's lots of unavoidable complexity. However, there are things that you can do to make it even more complicated for yourself. First of which was the kind of problem we saw at the start, where we had the data type conversion. And it's really important, it's particularly important when working with date time values, is that you use the correct data type, okay? Now, there are three key date time data types in Oracle database. Well, actually, it depends on which way you look at it. There's either 3 or there's 6. Okay, so the 3 core data types are date, timestamp, and interval. So dates and timestamps record a specific date and time, specific point in time. So 17th of January at 2 p.m., for example. An interval is a duration of time. Now, for timestamps and intervals, there are then also some subtypes of these. So dates, they're always dates, there's just plain dates, but timestamps can also be categorized as plain timestamp, a timestamp with a time zone, or a timestamp with a local time zone. So we can add extra time zone information in there. And in Oracle database, intervals are either year to month or day to second. You can't have years all the way down to seconds in terms of what you're recording and the precision related to them. So we'll look at these in a bit more detail in a second. So first thing to note, just very quickly, the smallest unit available for each of these. So in Oracle database, dates always include a time component down to the second. This is different from some other databases where a date is literally just day, month, year. There is no time component. So Oracle database dates always include a time, and that is down to the second. Timestamps can go right down to nanoseconds. So you can actually have 9 digits of fractional seconds stored for a timestamp. You don't have to, but you can do. The other thing, as I say, we'll talk about time zones in a lot more detail later on, but dates and plain timestamps have no time zone information. Timestamp with time zone, hopefully as the name implies, do in fact store time zone information. So these are all the kind of point in time values. as I said, intervals cover a duration, so a length of time. And there are two of these, year to month and day to second. And like I say, they don't overlap in any way. So an interval only stores years and months. It has no information about days and seconds. A day to second interval has no information about months and years. Now you can store more days than 31. You could have like 100 days, but that doesn't then convert into months, an interval of months. Okay, you have to have some conversion routine if you want to do that for you. So the smallest unit for interval year to month is month, and for day to second is a nanosecond. Now, those of you who are paying close attention will notice I've only listed 5 things here, and I said there was 6 data types. Like, what happened to local time zone, right? Timestamp with local time zone. So I'm going to cover time zones in a lot more detail towards the end of this session. But for now, all I'll say is this is kind of, I'd class it as a bit of a hybrid type. It has some of the properties of a plain timestamp and some of the properties of a timestamp with time zone. We'll get into more of that when we talk about time zones later on. So that's just a quick overview of the data types that are actually available. So we go back to the query we had at the start, and it's like we're checking where all the rows where this column is greater than this value. And first thing to note here is this string is not a date. It might look like a date, but as far as Oracle database is concerned, it is not a date. So what it tries to do is, assuming this date time column is, we'll assume it's a date for now, just keep code a bit simpler. It will try and convert this string to a date. So it will implicitly add a to-date conversion to it. And notice we've got the format here, YYYMMMDD. Where does that come from? That comes from the client. So different clients can have different settings for this, and they can change them partway through the session as well, right? So this is one of many reasons you could encounter this problem where a developer can have stuff and they go, works on my machine, it's all fine, what's the problem? Deploy to production, and the production has different settings for date formatting, which means that the whole thing falls over. So the basic solution here is just to make sure that you are always explicit. Whenever you have string values and you want to convert them to dates or timestamps or whatever, explicitly use the to-date function with the format mask that you want to use. So here I'm saying in day, month, year format. So this is great when you know what format you're working with, right? And most of the time you should know that. But there's a few scenarios where you've reasonable chance of expecting invalid data or data that does not match that format. A few common examples. Anytime you accept user input of any kind, you kind of, it often takes people a few goes to get things in exactly the right format, or maybe they just make some typos. So it's quite common when accepting user input that they'll make a mistake in that, use the incorrect format. The other common example is when you're importing data from other systems. Often somewhere in the process, the date format you were expecting gets lost, or the external data is just messy to begin with. Quite often when importing data from other systems, particularly from text files or CSV files, you can find that there could be junk, messy data in there. So there could be cleanup work that you need to do here. So the question here is, well, we've got some data and we know that occasionally the source, what we're trying to convert, may not work, but we don't want those errors, right? So classically what people do in the past, and I think many of probably have done at some point, is create like a custom isDate function. So you create a function, pass it a string, check if it does the conversion, and if it does, process appropriately. This is obviously extra work for you, things that you don't really want to have to do. So back in Oracle Database 12.2, so quite a while ago now, we added some functionality to help you with this. First up, the default on conversion error clause for casting. So the cast function we can use to convert an expression to a particular data type. So we're saying expression to the data type and the default value on conversion error. Now, you notice the format mask here is optional. I marked it in red because, again, this works off your client settings. If you do not explicitly state this, you could run into problems where different clients use different values. So although this parameter is optional, strongly urge you to consider it mandatory. So what we're doing is we're using this format mask, either explicit or implied, to do that conversion. And if the conversion fails, then the function will return this default value. Now, do note the value you are returning must be convertible to the target date type. If you are trying to convert things to dates and it fails, you cannot return the string, not a date, okay? You've either got to return some kind of magic date, like the 1st of January 1 AD or the 31st of December 9999, or null, okay? So it has to be a date value or convertible to a date value. So important to be aware of. So we've got to have those match up. So this is kind of nice, and it's a great way to make it easier to do these kind of casting. But I must admit, when I first learned about this, I was kind of a bit underwhelmed, right? Personally, I don't know, you tell me otherwise. I don't use the cast function itself very often, right? It's pretty rare I'll write cast, blah, 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 blah. However, it doesn't just apply to cast itself. It applies to all the casting functions, toDate, toNumber, toTimestamp, so on and so forth. So these are functions, I use them all day, every day, and we're going to be looking at a lot of examples in the session today. So this default on conversion error clause applies there. So what we could do is something like this and say toDate, if this string, let's say it's actually a bind variable, should be in a real application. If it can't convert, then return this default here. And notice I'm not returning a date here. I'm actually returning a string in the format I want, in day, month, year format. So we have to be able to convert into that. So this is handy if we've got some suitable default that we want or know or can actually use here when we can't convert to the data type. But sometimes you might want to check. You might know you've got some potentially dodgy data there, and you want to filter it out, or send it to an error processing report or something like that. And you want to test beforehand rather than actually doing the conversion. So to help with that, we've now got an inbuilt validate conversion function, which does this testing for you, right? It says, can we convert this expression to the target data type? It's pretty straightforward. Is this expression a date? Is it a timestamp? Again, format mask is optional. Strongly urge you to consider it actually a mandatory parameter. Make sure you always specify that format mask. So the big difference of using this over toDate or toTimestamp is it's kind of a pseudo Boolean function, in the sense that if the conversion succeeds, so we can convert this to the target data type, then it will return a 1. And if it can't, then it will return 0. So what we can do this, if we know or expect there might be some dodgy data in here, we can say only return the rows where the validation is true, and maybe a separate query where we can say find the stuff that couldn't be converted so we can do something else with it. All right. So as we saw, there's various functions we can use to do this date conversion, and by adding the default on conversion error clause, we can handle exceptions. Or validate conversion, we can test ahead of time and check, can we actually do this conversion? Will it succeed? And have different logic if it can or can't. So that's when we're trying to convert strings to dates. Now, another kind of common question that I've seen crop up is people say, well, how can I change the date format, right? How can I change the format for a date? I've stored a value in day, month, year format, and I want it year, month, day format, or, I want to change what format it is. Now, the first and most important thing to be aware of here is dates you are storing, or date values generally, and timestamp values too in Oracle database, have an internal format, right? You do not control that. It is a specific internal format for Oracle database, and that is how it knows that it is in fact a date or a timestamp value. It doesn't matter which format you use to actually insert the data, it's all converted to that internal representation. What happens when you select it, it is then displayed according to your NLS settings. So there are three key session settings you want to look at: the date timestamp and timestamp TZ, timestamp time zone formats, which control how those data types are displayed. So these are the default formats. And these are why we saw that problem with, we had a string that looked a bit like a date, and it converted on one person's machine. It didn't convert on the other person's machine because they had different NLS date formats. And I'll do a demo in a minute to show some examples of these. So if you select a date value in your client, it will be converted to these formats. If you want it in a specific format, you should to-char it. So you say to-char the date time or value with the format that you actually want here. And now I will say, actually, most of the time in applications, you're selecting the date timestamp value out of the database into your application. You really just want to bind it to date or timestamp variables in your app. Most of the time, you probably don't actually need to do this conversion. Save it for, really should be leaving it up to the end user, the end client, to decide how they want to display it, right? Many of you know, most of the world tends to use day, month, year as the standard format. However, America, they've got to be special, right? They prefer month, day, year formats. Like, hideously confusing. If you've ever worked across systems where people switch between these, can be hideously confusing. So generally, you want to leave it up to the end user, the client, to specify their format. But in some cases, you do want exact control over how it's actually displayed, and you'd use to-char to do this. So at this point, I'm going to jump over to a demo. So I see there's a couple of questions or comments. I'll address those. Oh, okay, yeah. All right, so some of the other things I'll cover in a minute. Okay, so first up, date literal value. So we are selecting a specific value. So we've got date, timestamp, and timestamp with time zone. So these are all in this format. So let's just run these, and we can see we are getting those values there. So notice the date literal has no time component, right? This is because in the SQL standard, dates don't have a time, okay? It comes from that. But as I said, in Oracle database, dates always have a time. By default, we say, by convention, we say it's midnight if you have a day with no time that you want to record. Timestamps have an hour, minutes, and seconds. They optionally have fractional seconds. So as I say, up to 9 digits of those. And you can also have the time zone. So Europe, London, I'm in the UK, so that's the time zone I'm in there. So that's date time literal values. Now, before we go on, just a quick little note on the TRUNC function. So we've got sysdate, and that returns, as I say, dates in Oracle database always return a date. There are occasions when you want to say this is a date with no time. And the classic way we do that is with TRUNC. What this does is it kind of rounds down to the smallest unit here. So we've got sysdate. That is date with the time, so it's currently 20 past 2 here, 1420. If we use we can specify different format masks to round down to. So here I'm rounding down to the hour, rounding down to the hour. There we go, that's better. So down to 2 p.m. By default, if we specify no mask, that's the day, so that's the start of today, so midnight today. And we could even go back to things like the start of the year. So this says, get the first of this year. So TRUNC is a handy little function to kind of remove or round down and effectively remove the time from a date. It can be useful in some cases. Okay, so let's move on. So let's look at these NLS settings. We'll start off, as I say, day, month, year format for our dates. And here, our string value matches it, so we can get all the values out of it. All good. Let's change it to year, month, day format. So the reverse, it no longer matches. So the whole thing falls over in a big error, okay? Because year, month, day, and we've got day, month, year, it's trying to date that effectively, and it's not going to work. Okay, so to overcome that, as I said, we want to be explicit and specify the format mask, day, month, year here. So we're still just kind of prove the point, oh, actually, I'll copy this here. Just to prove we are still in year, month, day format for the session, but we have overridden that and said explicitly we want day, month, year. So it doesn't matter what we change this to. It doesn't matter if we run on different machines. This is always going to work, right? Couple of important things still to be aware of, though, however. You should only to-date values that are strings, okay? What happens if we try and to-date something that is, in fact, a date? Well, we get an error, okay. Why is that? Because in order to date a date, you can't to-date a date, you can only to-date a string. So the database has to convert it to a string, which it does with that format mask we just set it to, and then to-date it back again, right? So the inputs for to-date, to-timestamp, etc. should be strings, okay, not dates or timestamps themselves. So another important thing, again, I see quite a people get caught out by this one where they are to-dating or to-timestamping something that is in fact already a date or timestamp. Okay, so when we're to-dating, make sure we're working with strings. Now, as I said, we've got these NLS settings to control the default formats. Now, one thing to note here is I've included in quotes here DT, TS, and TSTZ. A couple of reasons. So first thing to note here is you can put anything you want here in this format in quotes, and the database will display it as is. So whenever we select a date value that we've not to-charred explicitly, it will include the string DT at the start of it. Okay, so that's just a kind of general thing if you want add extra text when displaying these values. I've done it here to help make it clear the difference when I am selecting a value that is a date or a timestamp time zone. We can see just by looking at this little text here, which of these values it in fact actually is. All right, so we'll know which is which. Okay, and we can see what the current session parameters here are by querying NLS session parameters. And we can see those, we've got date time, and those are the formats we are using. You'll notice there is another little parameter coming here, the date language, English. I'm like, oh, interesting. How does that affecting things? Could that cause any trouble? And the answer is, of course, yes, it could, right? Okay. So there is, in fact, another parameter here we might need to watch out for. Let's set the date language to Spanish rather than English. Let's try and do this conversion. And it's not a valid month. What? Why is it not a valid month? Because January is not, the name of the first month in the Spanish language is enero, not January. So it's trying to convert Jan to it goes, I don't know what that is. I'm looking for ENE, enero, and it can't convert it. Okay. So if we want to be truly bulletproof, you should also specify the third parameter with the NLS date language. Okay, and this then keeps us absolutely bulletproof. I'm going to be a little bit naughty in this session and generally only stick to the first two parameters, mostly because some of these examples are already going to get quite complicated, and adding this in, it makes things even more complicated. But if you want to be absolutely certain, then you should include this NLS date language as well. So that's when we had Spanish. Let's go back and set it back to English. Now, as I said, if we wanted different formats, so we're trying to convert this day, month, year to year, month, day. And if it doesn't work, convert it to 31st of December, 1999. Okay. And the format masks don't line up. So we get the default value instead of the value we are actually trying to convert. Now, as I said, this default has to be in this format. If I do this default in day, month, year format, we're back to getting an error. So you still need to be careful here and kind of watch for things. Essentially, it is still trying to convert this using this format mask. So do watch out for that. Let's look at validate conversion. Now, one of the things you might want to do, sometimes you might actually, like say, you might expect that you've got data coming in different formats, particularly if you've got a generic file processing routine or something like that. What we can do is do some validate conversions and test different conversions. Is it in day month format? If it is, then to date it. Is it in year month day format? Then do that, and so on and so forth. And then, and if it's a format we don't recognize, return an error. So we can do that. So you can see now by passing it into my string to date function, we can try out these different formats, and you can see that they both actually work here. I'll just scroll up to make this a bit clearer. So we can see we've got it in day, month, year format, and database tested it and said it could convert and do that. We went for year, month, day, and again, it can convert. So there are situations where you actually might need to try out and test different formats and then do the conversion. Obviously, you'll need to know, depending on what exactly it is you're trying to achieve here. Okay, so now here's an interesting thing. Okay, I'm going to try and convert all of these to these strings, these date strings, to the format day, month, year. Who wants to take a guess over how this is actually going to be, what's going to happen here? So if it can't convert, we're going to get a null. Let's see if anyone's, what people think might happen here. I see there's a couple of comments come in while you have a think about that. So it's how to convert day. I'm not sure why you've got year, month, day, hour. I think when you say how to convert it, you need to be a bit more specific. Is that is that a date, in which case you're not converting it, you display it as you want, or is that a string you're trying to convert into date? And I'm not sure if the D before the year is a typo or you've meant that. And if so, if you could just be a bit clear about, explain a bit more about what you're asking by that format mask. Like, is this actually a date or a timestamp, or is it a string you are trying to convert to a date or a timestamp? And then use the format model as appropriate. And is there a specific SQL function to convert Unix time format? Keep that in mind. I'll come to that a little bit later. Okay, so only one person's being brave and having a guess here and saying, I'm going, all will work. So let's have a look. Let's see what will actually happen here. Aha, they all in fact do work, and they all in fact do convert to date values. And it's like, what? What? How does this work, right? You know, none of these actually, they're all similar to this format, but none of them actually match it exactly. And one other thing to note with when we've only got the 2-digit year, it's actually gone to the year 23 AD, right? The 23 years after 0, not 2023, because we don't know which century it is. Important thing, but they have all converted. And this is because the default format matching in Oracle database is flexible. So this format can match the full month, shortened month, and it doesn't matter what kind of punctuation you put in here. You could put in forward slashes, colons, semicolons. It will match them all. So this is actually quite handy. In a lot of use cases, it is useful because sometimes, you know, we know we're always going to be in this day, month, year format, but sometimes they might use colons, sometimes they might use hyphens, sometimes they might use slashes. A lot of times this is useful. Sometimes, however, it can cause unexpected problems, as we saw with this year 23 AD conversion here. Okay, so sometimes you say, no, be explicit, be exact, only match exactly what I've asked for here. So in order to do that, you need to use the FX modifier. So put that at the start and then say, only convert if it is exactly the same as the format mask we have asked for here. And you can see now we've gone for exact match, we're returning null. So none of those actually match exactly. They're all close, but not exact. So we'll return null in all those cases. So another question. So instead of using DDMMYYYY, could we use DDMM RRRR? I mean, yes, you can use DDMMRR, right? If I go back to this example here. So this, and I always forget, this does year matching as well. And you notice with the 2-digit year, it has now gone correctly to 2023, okay, with the inexact matching. But if I change this to, let's see if I've remembered rightly, change this to 1973, it goes to 1973. And it's like, what? Well, so this is, again, one where you need to be careful. RRR from, I think it's, if the year is 50 or above, up to 99, it will go to the century 19. If it's 0 to 49, I think, or it might be 50 to 51, I can't remember exactly, it will go to 2000. So again, if you've only got 2-digit years, in some cases, this might get you out of a pinch. But again, this is a slightly, slightly implicit thing. You really want to use 4-digit years as much as possible. Okay. I notice when we have the full 4-digit year, it always goes to 2023. You know, if I put 73 in there, it'll go to 2073. So you can use it. I would advise you not to, unless you really got no alternative. All right. Okay. How to make select to date default on conversion error from dual work. Okay. Okay. So the question common there. Let's find someone pasted this in select from dual. Right. So this is now using my sessions NLS settings. Do not rely on this, right? If you take one thing away from this, you should never just do this and rely on it. You should always, always, always put MMM DD at the end. Doing anything else is opening yourself up for a massive can of worms and bugs and who knows what down the future. You go, oh, we've got full control of our environments and it's all fine. I've seen problems happen because people assume this would all be fine and it wasn't. Okay. Never, just don't rely on the NLS setting being this. Okay. Always explicitly specify it. If you take one thing away from this, it's like be explicit and make sure you specify the formats you are looking for. Okay. Don't rely on those session settings. Okay. I hope that answers or helps clarify things, because otherwise, you know, it's just a time problem waiting to happen if you do not include this third second parameter. And arguably you really should set that third parameter as well, the NLS date language parameter too, to make sure it's in whichever language you want. I mean, it doesn't matter with things like this when it's all just numbers, but if you are spelling the month, then you should include that as well. Yeah, Eric, always use FX in the format. I don't know if you just joined, Eric, but we were just talking about the FX format matching and show that we need exact matching there. Okay, we need to move on. No worries. We've also got, we could also got a, oh no, I skipped a bit. So let's go the other way. Let's go dates to strings. And there are a huge number of formats here. I've just picked out a few just to show you that there is a large number. So the I is for ISO. This is the ISO weeks and years. So that's the first week of the year that includes a Thursday or the 4th of January. That's week 1 in the year. Here we've got the DY, day abbreviation, and the first, second, third, fourth of the month spelled out and the year spelled out. We've also got slightly wacky things like J is the Julian day, which is something like the day since 4712 or 4713 BC, before the Common Era. W is which week of the month it is. Okay, so we're in January, we're in the third or fourth week of January, which quarter of the year. There's lots of these. I'm not going to go through them all. Point is, there is lots. Just chances are, if you want a particular format, you can find it. There's also ones for formatting the actual time components, day, month, year. HH24, MISS. Fracture SSS is how many seconds have elapsed so far today. So you'll see this one, seconds in day, keeps increasing. The fractional seconds is the part, you know, this is how many microseconds, and time zone information. So lots of ways to format those. Like I say, most of the time you want to bind date values in the database to date variables in your application. Generally, you only need those if you want to fix client formatting, right? If you want to convert dates to timestamps, we can use cast here. And you can see we've converted those. And so we've added some extra information there. So we converted. Now notice with the timestamp with time zone, it's actually using the session time zone to do this. I'll talk about timestamps a bit more. Very briefly on literals. So literals for intervals, they have specific format. So we've got a day, hour to second, year to month. We've got 2 interval functions as well. Now these are interesting. They do not have a format mask parameter. okay, they have to either be in the SQL format. So this is days, hours, minutes, seconds, or this is ISO formats for durations, okay, and year, month. So you cannot change these. You have to actually make sure what you're doing is in this format. And if it's in, you're kind of stuck. Okay, you can't change. You can't actually add a format here. The other thing you might want to do is convert a numeric value into an interval. So here, all of these pairs do the same thing. So there are 86,400 seconds in a day. So both of these return a day. We can construct an hour, the 12th hour, 34 minutes past 12, and 34 minutes and 56 seconds past 12, or 12 hours. Well, that's how many seconds there are in that duration of the day. You can say this many month is in fact 99, and that many fractions of a year month. So these do the same thing. So the key thing here is they take fractional values. You just specify the unit that you're looking for. So these are both 1 day. Those are 12, 34 minutes, 56 seconds. And those are both 99 years and 1 month. Know what the value you're working with is, what units this is, and we can accept fractional values. Okay. Any last questions or comments on that before we move on? Okay. Good practice to aggregate interval. I will cover that one a tiny bit towards the end of the session. Okay. All right. We took longer on this bit than I expected. Okay, we need to get on this because there's still more to talk about. So things to take away from that: make sure you're explicit. If you know what the value is, you can use a literal or use the 2 functions with the format mask. If you expect data to be in invalid formats or need to handle unexpected formats, we can use the default on conversion error clause or validate conversion to test those. Okay, let's move on to date time arithmetic. And this is where things get really interesting. Okay, right. So first thing to note, the unit of arithmetic for dates is a day, and that's a number of days. For timestamps, it is an interval, and the units are whatever you specify, because you can say an interval is a number of hours, you can say it's a number of minutes, whatever, right? So if we want to add 1 day, you can say add 1 to a date or add an interval to a timestamp. Things get interesting when we start mixing and matching these, okay? So if we have got dates or numbers, the result is always a date. If we add and subtract durations as a number or from or to a date, the result is always a date. It's only a timestamp when it's a timestamp adding or subtracting intervals. What happens if we kind of want to get the duration between 2 date time values? So, date minus date, or date minus timestamp minus timestamp. So date minus date, hopefully, is like a fairly obvious number. Timestamp minus timestamp is an interval. But if any of the arguments to the subtraction here is an int timestamp, the resulting type is an interval. Now, at this point, you might notice there's a bit of kind of asymmetry in the values here, right? I might have expected, given the previous slide, everything was a date here, that all of these would be numbers. No, that's not the case, right? Very important to make sure you check very, very carefully what data types you are using with these comparisons and what result you get in the end. You can end up with things converting to different data types without you expecting it. Okay, so that's just a quick overview. What if we want to get the duration in seconds? All right, how we want to get a duration in seconds. Someone was asking about the Unix time, the epoch. So there's no epoch format in Oracle database. So those of you who don't know, Unix time started the 1st of January 1970 at midnight UTC. And it's counting the seconds since then, roughly, okay. So if we want the Unix time from a date, we subtract that date, 1st of January 1970 from now, and multiply it by the seconds in a day. That gives us the Unix epoch, okay. And if we want it in hours, you multiply by the number of hours in a day, so 24, and so on and so forth. Things are a bit more interesting when it comes to timestamps, because we can't just multiply this up. we've got to extract out all the specific components that we actually want out of that timestamp. So we've got a timestamp and we want its duration in the epoch, and we've got its epoch, and we've got an interval. We have to extract out each component and multiply by the number of seconds in that thing. So we've got to get the day, how many seconds in a day, the hour, how many seconds in an hour, the number of seconds in a minute, and add all those up. So it is a bit more fiddly when you want to convert time intervals into numeric durations of a fixed unit. Okay, so things are already getting a bit messy, but what happens if we need to add or remove months? Okay, so there's two kind of key ways. When you're working with dates, we can add months. So this add 1 month. And when we're working with timestamps, we can add an interval. But as I say, these behave slightly differently when it comes to the last day of the month. And I think this is something where it's just much easier to walk through a demo and show you what actually happens and start to cry a little bit. Okay. All right. So we'll just keep that in mind, bear that in a second. So just very quickly, as we show, we're doing the various comparisons to date plus number, date plus interval, date plus timestamp plus number. They all have date. Notice these all start date. It's only timestamp plus interval that gives a timestamp. If we are subtracting them from each other, then everything's an interval unless both arguments are dates. So as I said, bit of asymmetry. They work slightly different ways, these depending on which way we're going in terms of which types we're going to get in the end. All right, so we're going to say looking at the epoch. So we can do it with our dates or timestamps. And notice I've got the time zone. I'm explicitly saying it's UTC here. So by default, the timestamp, that would be 19,300 whatever days. To convert that into a number of seconds, we need to extract all of those out. It's a bit of a faff. If you're wondering why I'm using this cross apply, I'll give a little hat tip to Lucas Eder. Basically, it's a way for us to kind of declare column variables, so I can reuse the result of this in the subquery. If you want to, I'll share this link later if you want to have a look and play around with that. Okay, so now we saw we use extract on timestamps, but this only works if the data type has that particular value. As I said, ISO dates have no hour, minute, seconds, and we've implemented according to that. So you cannot extract the hours from a date, or the minutes, or the seconds. Okay, all right. Now where things get really interesting. Now, hopefully, it's fairly obvious that you cannot add a fixed number of days as a month, right? Some months have 31 days, some don't. So if we add 31 days, the 1st of February, we end up with the 4th of March, okay? So we need to add months instead. So let's look at this. We'll add some months for dates and add some intervals for our timestamps. So we can do that. That's all good. We're starting with the 1st of the month. What happens if we start with the end of the month? Right, now this is where it gets really interesting, as I said. 31st of January and the 28th of February are both the end of the month. So the resulting date is the last day in that month, the following month. So 28th February, 31st of March. This does not work with adding month intervals. Adding a month interval preserves the date, the day of the month. There is no 31st of February. There never has been and there never will be. Well, maybe I won't say never will be, but there never has been, right? So we get an error because there is no 31st of February. So we cannot just add an interval of a month here. It's like, okay, right, this is where things are starting to get messy, right? And fun and difficult to deal with. Okay, so that's a problem. What happens? You might go, okay, well, let's just use add months to add a timestamp to deal with the timestamp. So we can do that. I mean, it kind of works, but notice the value we've got back now is now a date. We've kind of ended up with an unexpected conversion here. Add months only talks dates. It does not talk timestamps. Okay, so we can end up with unexpected conversions here. The fun I haven't finished yet. I haven't finished with all the fun. Right, let's add months to the 28th of the month. Okay, we'll start off with the 28th of January. It's 28 days in every month. So notice, because we start with the 28th of January, that is not the last of the month. All the resulting dates are on the 28th. However, what happens if we start on the 28th of February this year on a non-leap year? The 28th of February is the last of the month this year, or in non-leap years. So the results are all the last day in the month after that. It's like, no, right? Okay. And before you kind of start saying this is a bug, this is going to change, this is all documented behavior, right? That interval stuff is part of the SQL standard. It's been like this in Oracle database for as long as I can remember. This is not going to change, right? Okay. You might not like it, but this is some of the unavoidable complexity I was talking about when it comes to dealing with this. A month is not a fixed unit of time. Okay. Anyway. So how can we get around this? Well, one way is if we avoid this kind of problem, make sure we always go to the end of the month if we needed to. So working with dates, we can trunc to get the start of the month and work out, then add our months on, and the last day function returns the last day of the month. Okay, so notice we can do that, and we're now got the last day of the month. Okay, but as I said, trunc, or did I say? I can't remember. Trunc only deals with, like add months only deals with dates. Trunc also only deals with dates, as does last day. So we put timestamps into those, we get back dates. Okay, all right, all good fun. Okay, so what if we want to do this with timestamps? Here's a little trick I've come up with. So if we're on the last day of the month for a timestamp, we can add a day to make it the first of the next month. Then we can add a month to make it the first of the next month, and then subtract one day to go back to the last day of the previous month. Okay, so notice now we can add our intervals to the end of the month and avoid that error that we had before. Okay, and let's just check what happens when we go put our 28th of February as our input. Do we still end up with the last day of the month for each of those? Yes, we do. Now, do you want to use these? Maybe, I don't know. This is where you've got to think really carefully about what does it mean to add a month to the 30th, right? What result do you expect at the end? If you add a month to the 31st day of a month, what result do you expect at the end? And then a lot of the time, this is something where your business should have a standard definition and decide how they want to handle this. You need to speak to people and find out what they want it to do. Okay. So that's adding and subtracting months. What do we find the months, how many months have elapsed between two dates or two timestamps? Well, we can use months between when we're working with dates. So here I'm just adding a number of months, so we can find the months between. Actually, I should have really added a month day here so you could see what was going on. So how many months between them? And we just added 1 month each time, so we get a round number of months. Now, then another interesting thing is, if it's not the same day of the month, it uses a 31-day month to calculate fractions, to calculate part of a month. Okay, so if we go for the 15th, and so the dates are all the 16th, sorry, we had 15 days. We end up with something which is not quite a whole, not quite half a month. And it's like, why is that? Because we're talking 15 31st. There's 31 days and months between always works on 31-day months. Doesn't matter which month you are using, it's always a 31-day month. So notice we end up with this fraction here. This can lead to some interesting logic if we try and figure out how many months and days there are between two values. So let's start with the 28th of February, and we're going to add some days on. And we'll start off 28th of the 1st. How many days are there between the 28th of February and the 1st of March? Well, 0, 1, usually 0, 1 if there's a leap. Yeah, but because months between uses a 31-day month, it's decided that there's actually 4 days between them. And it's like, what? Right, okay, it's like, all right. So, again, this is all documented behavior, how it works, and stuff that is not going to change. So you know, if your head's not hurting at this, my head certainly hurts whenever dealing with this. If yours isn't, then, you know, just make sure you document and comment and say what the heck you're expecting here. Working with intervals and timestamps and intervals. So we use num to year month interval to add them. The rounding point for intervals is the 16th. So notice I'm going up to the 15th, just before midnight on the 16th and the 15th. And to actually, normally when you subtract two timestamps, you get a day to second interval. To convert it to a year to month, we have to bracket it for the expression so it knows that we want the result of this. We say this is a year to month, right? And notice we get those as year to month expressions. So notice just before midnight on the 16th isn't a month, but it rounds up a month on the 16th. So we can do that. We can use year to month if we want interval durations. Very quickly to finish up on this, if we want to add durations, intervals, you can specify as many different, cursor selection isn't working, right? So you can specify different things, keep adding, subtracting them however you want, but only if they are compatible, right? Year to month and day to second are not compatible, so the database won't let you do this. Okay, all clear? Clear as mud? Head hurts? Yeah, I think I might need to go for a bit of a lie down after this to kind of figure out what's actually going on here. Any quick questions or comments on that before we move on? I know if you're struggling at this point, I always need to like triple check whenever doing any of this kind of logic and understand what do we want here? What's the end result? What are we trying to achieve? So, okay. All right. So I hope either, you know, I've said everything I need to say, or you're just like stunned, like, I don't know, still trying to process what's going on. I said the recording will be available if you want it. Can I share that SQL file? Yeah, I've uploaded it to Live SQL, so if you hang around to the end, I'll share a link to that so you can try this all out for yourself. All right. So just to recap on that, my thing's gone here. The thing to remember here is dates and timestamps use different data types for their arithmetic. Okay, and if you are mixing and matching these data types, unexpected weird things can happen. Also, if you need to add or remove months are not a fixed length of time. So again, unexpected things can happen, particularly when you're dealing with month ends. Think very carefully, write lots of test cases, test the heck out of it, you know. And I haven't even talked about leap years in detail, right? That's another extra complication that can arise. Okay. All right. So we've talked about, you know, the actual date time, the data types. We talked about arithmetic, and something I said I would cover at the end, time zones. Okay. So one thing people occasionally I've seen ask is like, well, what time zone is my data in? Now, the first thing to note here is if there is no time zone information in your data, right? So here we've just got a plain date and a plain timestamp. There is no time zone with it. The answer is nobody knows, right? Nobody knows. So if you've got an application, you know, and there's no documentation around it saying the dates or the values here, the timestamps are stored in UTC or London time or whatever time it is, then you have to guess, right? It's lost information, okay? So it's important to be aware of this. If you need to know what that time zone is, you have to actually encode it in the timestamp somehow or another. So let's say timestamps, you can include the time zone definition. You cannot do this with dates. And this is, you know, again, this is working with actual proper data types. If you've got a string, which is just like 17th of January, whatever, there's no time zone here. Okay. So another important question is to ask here is like, well, do you need the time zone? Do you actually need to record that information specifically? So and really what I'm saying here is, do you want to use a timestamp with time zone data type that preserves that? The answer to that is yes. Then you should use timestamp with time zone. And this, if you joined the session I had towards the end of last year, where we were talking about designing a database to store scheduling for sporting events, international sporting events. They're things that happen in the future at specific locations, and the time zone is useful, a property of when it is scheduled. You need to know it is scheduled at 2 p.m. London time, or 2 p.m. Berlin time, or 2 p.m. Kolkata time, or whatever, right? If that information is specific and useful, make sure you use a timestamp with time zone. On the other hand, there's a lot of kind of system information. So, things like insert dates, create dates, update dates for data in your database, when it actually happened, use UTC. Now, you could use timestamp with time zone that actually encodes UTC always. You could use a plain timestamp, or you could use timestamp with local time zone. So it was a question right before we even started about local time zones. This is an interesting type. So timestamp doesn't store the time zone. Timestamp with time zone does store the time zone. Timestamp with local time does not store the time zone. When you save a value, the database converts it to the database time zone. And when you query that value and fetch it, it converts it to the session time zone. Okay. And again, I've got an example demos, show that in a minute. So one thing you might want to say is, well, we've got values in one particular time zone. How do we change it to another one? It's in UTC, and we need to convert it to New York time or something like that. So a few things to be aware of here. We can use from time zone to add time zone information to a type, and these at expressions to change which time zone it is. So I'll jump over to the demo for these. So I'll set my time zone to London. So the sys functions, notice, these return information from the database server. Doesn't matter what my session time zone is, these will return the same. The current date and timestamp are converted to the session time zone. So you notice they're just before 3 o'clock there. So I'll save that. If I convert it to India time, Kolkata time, they are now at 8:30, nearly 8:30 in the evening, right? Whereas the sys values are the same. Let's go back to session time, UTC. Let's create a data table with these different timestamp values. And I'm going to insert various values, the 1st of January and September, without time zone, and in Asia, and I'm going to set my session time zone. So there's going to be some various implicit conversions going on here. I'll set my time zone to UTC. Let's just close those back down again. So the plain timestamp, there is no time zone, it's just that value. Timestamp with time zone, it then adds in the session time zone. So notice all these are just the 1st of September. Say 1st of September in London time is on daylight saving, which is +1 hour. So notice this is now +1 hour. Okay, but when we inserted this into a timestamp with local time zone, it says, okay, well, it's a timestamp. It's implicitly added Europe, London in here. It's like sneakily added that in here, which is +1 hour, and then converts it to the database time zone. So -1 hour to go to 0. That's actually the 31st of August, 11 p.m. Okay, right. We can end up with unexpected implicit conversions going on here. So that's when we've got it in UTC, right? So this time, these values will stay the same. It doesn't matter what my session time zone is. I'm going to just pin that. If I convert my session time to somewhere else, Asia, Kolkata, I like India time because it's got a 30-minute offset, making it pretty obvious that values are different, right? You'll notice that these values, those local time zone values, have all changed to my session time zone, right? Okay, so this is where you need to be super careful. What value are you inserting? Does it have a timestamp? Is it going into a local time zone? What time zone are you fetching it out in? You know, be explicit with all this stuff, and you know, get that value out. You know, you need to be super careful with this, or you can end up with unexpected values going on. It can be useful, but it can also lead to unexpected outcomes. Okay, just show add a time zone. I know, go quickly because we've kind of passed the hour already, but just a little bit left to cover. If we want to add, we've got plain timestamps. If we want to add a time zone to that, we use from time zone. But sys time zone always has a time zone. You cannot use from time zone on values timestamps that already have a time zone. Okay, right. More interesting this. So we'd have to cast it to a timestamp first. All right. Let's go back to UTC. And we can use the at time zone to convert from one time zone from another. So midnight on January of age or Kolkata, if we convert that to UTC, here it's actually just before 6:30 p.m. the previous day. At local uses my session time zone, and this just converts it. This now, we've got a timestamp with no time zone, and we're converting it to a time zone. It is then implicitly added my session time zone and then done the conversion. So if I just pin that, and then we'll change the time zone to Asia, Kolkata, you'll notice, okay, so the values are different here. So the first one was fine. With local, we've now gone, so that was midnight UTC, this is midnight Kolkata. But when we did midnight without a time zone, UTC is still midnight. But here it's gone midnight at Asia Kolkata time, and then convert that to UTC. It's like, okay, so you have to be careful here, right? You need to know what you're asking for. So there were, like I said, there's a question right back at the very start. Do you need to convert? I mean, obviously, you need to know what your requirement. I think know what people are expecting. What do people want to see? Okay, and be super careful because these implicit conversions or unexpected conversions can happen all over the shop. A couple of last quick things to cover up. There is new time which works with dates. So Pacific Standard Time and GMT, 8 hours, but it has very, very limited time zone support. If notably, it doesn't even have UTC. There's very few cases where you'll actually be able to use this. One other thing to say is that Oracle database is time zone aware. So the clocks go forward, spring forward, yeah. So the end of March in the UK, the clocks go forward, and at the end of October, they go back. So because I've got that time zone, Europe, London, notice it knows there are only 23 hours in that day. And there is in fact 25 hours, a day and an hour when we go back. So it is time zone aware as long as you use the region, okay? So it is daylight savings aware, all right? And this can lead to things, how many hours of days and hours have elapsed. If we've got it plain timestamps or these times in London, okay, or in the UK generally. All right. Feels like a roller coaster ride in a good way. Yeah, exactly. Like I say, I know I've had to whip through some of this pretty quick, but as I say, there are scripts available, and the recording is up, will be up later this week as well. So just to recap quickly on time zone, like I say, there is a lot of situations where you can end up with implicit conversions, perhaps slightly unexpectedly. If you store a timestamp with local time zone on the way on when storing it, it converts to the database time zone. When fetching it, it returns in the client's time zone. Okay, be careful when there is a mismatch between those, and particularly if you're inserting timestamps that have no time zone information to start with. Daylight savings. If you want to do that, you have to use the region name, right? So it has to be Europe, London, not the hour 000, right? Or 0 hours, 0 minutes, because that is a fixed offset. All right then, recap quickly what we covered. So as we saw, there's three core data types for date, time, and durations, date, timestamp, and interval. Make sure you use the correct one. Watch out for implicit conversions. Be explicit. Do the explicit conversions if you need it. When it comes to arithmetic, some durations are in a number of days, some are in intervals. Okay, make sure you check your data types and your logic very, very carefully. And months are not a fixed length of time. All sorts of weird and wonderful things can happen if you want to work in terms of months. As we saw with time zones, If you need the time zone information, store it explicitly, timestamp with time zone. Otherwise, store everything in UTC. That could be explicit or implied, but don't pick some random time zone. Generally, we thoroughly recommend you stick to UTC. It makes everything so much easier. And there are lots of ways you can convert to time zones. Okay. And finally, just kind of go back where we started. As I said, there is a lot of complexity when it comes to date time values and working across them. Lots of weird and wonderful things can happen, and a lot of that is just the complexity of how these things work. They are not fixed units of time, things like years and months. Okay, unexpected stuff can happen. Test thoroughly, make sure you know what's happening. As I said, if you want the scripts from this, I've uploaded them to Live SQL, so you can follow this bit.ly or the QR. So test and try them out and review the recording when it's available. I'll hang around for a few more bonus questions if you want, but for now, as we're kind of a fair bit past the hour, I'm sure some of you need to get on. So all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. Stay safe, and I hope to see you again next time. All right, cheerio.